Hello. Welcome to episode number 84 of CXO Talk. Today we're going to talk about data and analytics. I'm Michael Krigsman, and my co-host Vala Afshar is a weary Vala today. He's the weary Vala Afshar because he was in Bali this week, and he spent like 2 days traveling in each direction, and he was there for 2 days, and he actually just got back. And so he's not with us today. And Vala, if you're out there, we're thinking of you. But we're going to have a great show, and we're here today joined by Michael Wu, who is the chief scientist at Lithium Technologies. Michael, how are you?
I'm doing fine, thank you.
Well, it's great that you're here with us, and today we're going to learn about data and analytics. So let's start. Give us a sense of your personal background and tell us a little bit about Lithium and your role in what you do at Lithium.
Okay, so my background, I would say that, well, where do you want to start?
Well,
should I start when I was born?
you know, we have had people on CXO Talk start, you know, during the time sort of leading up to high school and then high school and college. But how about your more recent work experience?
Cool. Okay, yeah. So I'm the chief scientist at Lithium. So some people call that a data scientist, but you know, to me, they are the same. You know, basically we crunch numbers, test models, and build models to predict things. You know, in this case, we're trying to understand social media, customer behavior on different social channels, and predict their behavior, and you know, predict what's the effect of their behavior and what their effects on business. So that's in short, you know, the focus of my research. And what I do day to day consists of, you know, everything from prototyping algorithm, writing codes, to thought leadership, and, you know, for example, participating in this show.
So,
and yeah, so I was going to tell a little bit about Lithium. So Lithium is a social customer experience platform. So we help big brands connect better to their customers, and so that's basically our mission. And we do that 3 different ways. You know, basically, we provide a community platform that allow brands to build a community for their most passionate customers, to basically help them advocate about their product, be advocates of their products, and self-support. And we also have a social media response portal. Basically, it's one place where you can respond to all the conversations on social media, on Twitter, on Facebook, on, you know, Google Plus, wherever you know those conversations may be. And finally, we recently acquired Clout, and that's also another platform where we could help brands connect to the influencers that are relevant to their brand, and basically help them scale their marketing efforts and create earned medias.
So you're the chief scientist at Lithium, which means so actually, yeah. So what does that mean? What does the chief scientist actually do?
What we actually do, well, like, it's a lot of things. Like I said, a large part of it is crunching numbers and building models and testing those models. And once, you know, we built a model and validated that it actually works and actually is predictive, then, you know, like one of my my professor used to tell me that, you know, as a scientist, you have 2 missions in life. You know, one is you have to do good research to advance the field, and 2 is that you have to essentially disseminate the knowledge and educate people. If you don't do that, basically knowledge gets, you know, shelved away on the shelf somewhere, and nobody benefits from that. So that's in essence what I do.
So as we talk about analytics, I know a big focus of your work is creating very practical results. And so why don't we start with some examples of big data and how it's useful and how big data can give us non-intuitive insight or understanding about what's going on. So give us a couple of examples.
Okay, so let me cite an example not from my work, but I think this is a really interesting example. So there's a company called Zest Finance, and basically, they're basically you can apply for loans there. And what's interesting is that they find that when people fill out the loan application form with only uppercase or lowercase letters, they're more likely to default. So that's interesting, right? I mean, that's something that you wouldn't have expected, right? That's something that, you probably expect that, like their payment patterns and their financial situation, all the traditional, underwriting kind of mechanism, all the things that they look at when they underwrite, those are the factor that will affect, the loan default rate. But it turns out that, the way that a person types or fill out the form actually matters in somehow, right? We don't exactly know what the mechanism is yet, but we could hypothesize, that maybe people who fill out the form with proper lettering cases, right? They're more careful, they're more detail oriented, therefore they're probably more successful and more better off financially and better able to pay off the loan. Or so that maybe that's a hypothesized mechanism, right? But we don't actually know what the mechanism is. But it is possible that could be a mechanism.
Mm-hmm.
But yeah, but this is what you can find. You can find these unexpected factors. So what they did is that they actually leveraged these insights, right? So the data is really just pages and pages of loan application, but the insights and the information that they derive from these data is that people actually have a lower default rate when they actually fill out the form with proper cases, application.
So you don't know what the reason is, but you're able to develop formulas and analyze the data in order to develop basically causality, predictive causality. Is that a correct way to say it?
Yeah, so the causality could go either way, right? So we're not sure whether the causality is yet, but that remains to be tested, right? So this is what they find is that there is a correlation, right? So and when they actually leverage this insights and put it in action, see, okay, now if I give people more people, if I use this as one of the factor in my underwriting, and determine, it's not the only determinant, but it also adds to the traditional factors that you consider. And then what they see is that they can actually lower their overall default rate, right? So that means that in this case it is causal, right? So if they actually take actions on this and it didn't affect their loan default rate, then we would know that it's actually not causal, right? So whether it's causal, the analysis will give you correlation, and when you actually experiment with it and try out, that's when you are able to figure out whether it's causal or not.
So the analysis, you said, gives you a correlation, but then you actually have to run experiments in the real world in order to determine the causality?
That's right. Yeah, that's actually the easiest way to determine, to figure out causality is to experiment with it, right? I mean, traditionally, I think in the media industry, very similar things happen, is that, you could, people buy medias but they don't really know whether it's actually having an effect on their sales or their business KPI. Right? What they see is a correlation, right? When they show the ads, sales goes up, but then it could be the other way, right? I mean, it could be people, are buying your stuff. That's why they like to look at your ad to find out more about you. But so the way to actually prove that is actually causal is that they could just shut off the ad, right? And then see if it comes back down, and then show the ads again, see if it goes back up, right? So the fact that you can experiment with it, you could turn it on, turn it off at any time, and then your business KPI actually follows that. that's a sign of causality, right?
Mhm. So now you mentioned differences between how data is analyzed in the present and the past. And so before we go deeper into the data science aspect, maybe give us some more background or explanation about data collection and analysis in the past versus today, using modern techniques like you're involved with in developing.
Yeah, so I think, there isn't any business that don't use data. I think throughout the history of business, we've been using data all along. It's just that today we have much more data and we can collect that much more efficiently and store and retrieve it much more efficiently. So and if we want to kind of understand like how data is being used previously before they were big data technology, then let's take a look at, in a typical scenario. Say, when you have a problem that you want to address, a business problem. And typically, you start with that problem, right? You encounter some problem, and you ask your analyst to go and collect the data. And then, so the data that you collected is collected specifically to address those problems, right? That's why they are highly relevant. So as a result, like the traditional use of data is very relevant. But with big data technology such as Hadoop and Hive and Pig and all this NoSQL technology, basically what it allows us to do is that now you can actually collect data before you even have a question, right? So you can collect data irrespective of any purpose or problem in mind, right? So you could collect it anyway, right? Because it's cheap and it's not expensive. So what that does is that it makes the data a lot more noisier, right? Because it's not collected to solve any particular problem. So when you actually do have a problem, now you have to go look at your big data store and basically filter out those data that are not relevant to the problem.
So in the past, you had to be very specific about the problem you were trying to solve, and therefore the data you were that you needed to collect. Whereas now you can be like a big data, a large vacuum cleaner,
Yep,
collecting
just suck up everything. Yeah.
and then
Yeah,
you can analyze it, operate on it later, and that
that's
means
right.
you can formulate the questions subsequently as well.
That's right. I mean, that's one of the advantage, right? You can also look at what interesting problem can you address with the data that you have, as well as going the traditional way, right? Traditional way, you start with the problem, and now with data, you can also reverse. But typically, in most business, you still start with the problem. It's just that now you have to have extra step in filtering out, the irrelevant data, because some data may not be relevant for you to address the problem.
But what about really large companies like I'm thinking of, say, Google or Facebook, or at a larger scale, the NSA? I mean, it seems these
Hmm.
companies are just collecting everything. These companies and the government just collect everything they can get their hands on,
That's right.
store it. Uh-huh.
Yeah.
So in that case,
Well,
it's not deterministic at all, right? You're just whatever data we can get is good. Any data is good data. Is that an accurate statement?
well, any data is good data. It's depends on what the problem. Because, well, okay, I would say that's not completely true. I mean,
Mhm.
I think it's true in the kind of idealistic case, right? Because you don't know what problem you may have in the future. Right. So, say I collected some. Okay. So, for example, the example was Zest Finance, right? They actually, I mean, they actually did not ask people, do you fill out your form in upper and lowercase, but they just have the information anyway, right? They have that information is actually available. It's not explicit, but you can actually look at all the application form and actually look at whether people fill out the forms with the proper casing capitalization, or they only use upper and lowercase, right? Upper or lowercase. So that's information that's available in the data, right? It may be seen or considered irrelevant before, but it's later when you actually do the analysis, it turns out it's actually not irrelevant. It's actually correlated, right? And then when you actually do experiment and test it in the real world, you actually found that to be causal. It's actually predictive. So it's actually very relevant in that case, right? Um, so I think that you may not actually know what the data is useful, right, in the future. I mean, it may not be useful for you now, but in the future, who knows, right?
So, so there's a transformation then that has to take place where you are making some broad assumptions about the type of problem that you may want to solve and the type of data that is available to you. And tell us, so now lead us through the kind of transformation that has to take place and the logic process that gets you from this large vacuum cleaning mass of data that we're sucking up to something that is useful and ultimately actionable.
Yeah, so today what big data technology enables business do is really, I would say, still at the, largely in the infrastructure layer. All this big data technology that you heard of, Hadoop, Hive, and all this, big data technology, they work at the infrastructure layer, right? But what business really want is the insights, right? That they could actually, the information, the insight that will help them make better decisions, right? For example, whether they give this person a loan or not, right? So that's in the insight, one of these insights, surprising insight, is that actually whether people fill out the form with the proper capitalization is actually important determinant whether they're default or not, right? So so those are the insight that business want, right? So the data is actually just the application form that's stored. You could search it, and retrieve it, and so those are actually, I would say, necessary. But what that means is that the big data technology today is actually not meeting the needs of most business yet. I mean, what they do really well is the foundation, the infrastructure layer. What the businesses want is actually to get the insights from those data, right? So so what we need is basically analytics and data visualizations that will help us crunch this data and to extract these information and insights and make them available to the business decision makers so they can actually take action on those insights, right? And I think that the next phase of big data revolution will be essentially a proliferation of these analytics algorithms, very general algorithm that's out there for people to kind of take advantage, right? For example, you could have, Cloud, for example, is an influence algorithm, right? If you give me your data, I will calculate the influence. I could figure out the influencer for you, and in the future, maybe there will be more these type of algorithms. If you give me the data for this person's tweet, right, I could figure out whether they're male or female, their age, from just what they talk about, what their linguistic profile, right? I could figure. So there may be these type of algorithm that's provided as a service that you could use, right? I mean.
But when I think of how most companies use data today, and when I think about the products that enterprise software companies provide, as far as I can tell, for the most part, it's collecting data and then operating on that data, looking backwards. So now you have a dashboard that really is, in truth, even though these companies, software companies, call it analytics, in truth, what it really is a pretty visual story summarizing their data.
Yeah,
and you're talking about something different than that.
Yeah, yeah. I mean, I think that's big data has this maturity journey as well. I think people need to get sophisticated, to learn about how to use data and how to use these algorithms, and so speaking about getting from raw data to the information, the insights that people actually want, right? There's actually three category or three classes of I think analytics that people can do to get you the insights, right? So, I mean, the first class is basically what you just described, right? These are what I call descriptive analytics, right? And these are uh, usually show them in dashboards, right? What you see in the dashboard is a summary of what has happened, right? It's a summary of historical data that you have collected, um, and whether they show in aggregated in some whether they sum it up or average it or do some simple computation on it, it's a summary, right? So those are descriptive analytics, and I would say like probably 80% of most of the analytics that most companies do are fall into that category, right? It would be descriptive analytics.
So it's
But
basically
then,
it's
yeah.
basically a summary report,
Hmm.
usually presented in a dashboard visual format. Only now we can say, well, it's also mobile responsive and it's got all sorts of fancy
Yeah,
features. But basically, you're talking about reporting.
that's right. Yeah, so that's what I call descriptive analytics, right? That's basically you just trying to summarize what has happened.
Hmm.
But there's also two other classes of analytics that's really useful for people to essentially get from data to insights, right? I mean, one is the next class is, we talked about this a little bit, right? Is predictive analytics, and then the next class, if you're more advanced, then you do prescriptive analytics, right? So usually, the maturity of I think anybody or even whether it's a company or a person, right? You always start with descriptive analytics, and then if you get enough data, you become more sophisticated, then you could actually build predictive analytics, and then if you are more advanced, and then you do essentially prescriptive analytics, right?
Okay, so we have descriptive analytics, which is essentially pretty reporting,
Hmm.
oftentimes positioned by software companies as predictive analytics, even though it's really not. Then we have predictive analytics that tell us the future in a sense. And
Hmm.
then we have prescriptive analytics. And so drill down a bit in the differences between predictive and prescriptive
Okay.
analytics.
Yeah, so that's very interesting. So in some way, okay, I mean, I would say that, some people call descriptive analytics, these summary reports, predictive analytics. I think in some cases they can be used, right? I think these are situations I would say, when the dynamics changes very slowly, right? For example, if you want to predict um, whether tomorrow is going to rain or not, right? You could always say it's the same as today, right? Because weather doesn't changes very abruptly, right? So if you just predict the same as today, then you will pretty much get it right most of the time. And a lot of, you won't, it's probably not good enough, you know, um, but you'll get it pretty close. Um, so one way, I would say a simplest type of predictive analytic is a trend line, right? I mean that a trend line is a predictive analytics that everybody is familiar with, right? You look at the data and they follow some trend, and basically you could see, okay, if you continue to follow this trend, then tomorrow or in the future um, it will be this value, right? So if it gets hotter and hotter, then the summer is coming, right? Or right now it's getting colder and colder as the winter is coming, right? Then you know that tomorrow is probably going to follow a similar trend, right? So that a trend line is the simplest, I would say, type of predictive analytics. But I would say that predictive analytics. I want to emphasize a point is that they don't have to predict in the time domain. They don't have to predict. I would say in future, right? I mean, you can actually predict things in the past as well. I mean, but these are what I call the general predictive analytics. Right? They don't basically in this case you are trying to use data that you have to predict data that you don't have. That's what predictive analytics really allow you to do.
Hmm.
Right? So in the case of temporal prediction, right? When you try to predict the future, the data that you have are historical data, right? And the data that you don't have is future data. which you can never have, right? Nobody can actually go to the future and measure what happens in the future, right? So all predictions about the future are actually what we, even though, they look the same. If I predict tomorrow's weather is going to be like 60 degree, right? I could predict that. I mean that's a number, right? You could plot it on the same graph. You could store it and retrieve it exactly the same way as the measure data that you can actually measure today's data. But notice that the difference is here, right? Tomorrow's temperature is not actually measured, right? Nobody can actually measure tomorrow's temperature. You can't go to the future tomorrow and measure that tomorrow is going to be 6 degrees and come back and report it, right? That tomorrow's temperature is actually predicted. It's actually a result of computation. It's the output of some model. It's not being measured, right? So that's one distinction that I wanted to draw, get people to understand. And if you understand that, then basically, predictive analytics is really simple, right? It's basically anything that you put into a model, right? The output of the model tells you something that you don't already know, right? That you don't have, right? And those are basically predictive analytics, right? So I would say, social media, there are a couple of types of predictive analytics that's actually people are already familiar with. For example, sentiment analysis. That's actually a predictive analytics. Sentiment analysis. Nobody actually go out and report that their sentiment is positive for Apple or the Android or whatever, right? They just say, I love my iPhone, I love my new Android, or they'll speak it in natural language, right? So the natural language are the data that we have. These are the input, right? And the model actually look at these, use linguistic, processing, natural language processing, and statistical model, to build a model. And then so when people use these type of language, then that's typically means that they have positive sentiment or negative sentiment, right? So it's actually computed. It's actually not actually being measured. So
okay, let's come back to that in a moment. But we have a comment from Twitter, and I'll just tell everybody we're talking with Michael Wu, who is the chief scientist of Lithium and one of the top practical data scientists in the world. And so this is your opportunity to ask him whatever you want. And so I encourage you to ask questions. But we have a comment from Alan Duncan, who is an analytics analyst at Gartner. And he makes the point, talking about the type of data collection that you were discussing earlier. So Alan says, if you don't have a problem, what's the point of collecting data? Data only exists for some purpose, and he calls it horse feathers.
Well, I mean, I think that's okay. I would say that it depends on your time horizon, right? If your time horizon is, say, a few years, right? If it's a problem that you're never going to be dealt with in a year or two, or 5 years or something like that, then it's probably irrelevant to you. You probably don't care, right? But for if you're talking about the NSA or something like that, right? Their time horizon is much longer, right? So they to understand, or whether a terrorist or you may have to look back to where they were born, 20 years ago, or their all-day behavior. So all this data become important when you actually look, when your time horizon is much longer, right? So it depends on different types of problem essentially have I would say different time horizon, right? Different time scale, right? For business, because business kind of I would say changes fairly rapidly, right? So the market changes pretty quickly. So I would say things that are maybe too old or too outdated, maybe you don't have to keep them, right? But for an organization like NSA or somebody who the problem that they deal with have a much longer time horizon, then you do have to keep those data. Even though, so the thing is that they may not have value for you today, right? But they may be valuable 20 years later, right? And you don't know that, right? I mean, the problem may not appear today, but the problem may arise 20 years later, right? But if you wait until 20 years later and say, oh, and then you realize that, oh shoot, I did not collect that data, then then it's too late, right?
So relevance then is, so time is clearly a function of relevance, or relevance is a function of time plus other factors.
That's right. It's I would say that it's context, right? Relevance is context specific. Context specific means is relevant to who, when, and where, right? For example, like if I'm traveling, like a few weeks ago, I was traveling in Budapest, so the weather there, the traffic there, is really relevant to me, right? It may not be relevant to you, right? Because you're not there, right? But this week I come back to San Francisco, right? And so the weather there or the traffic there is no longer relevant to me. I don't really care about it, right? So that's so if I have to keep track of the data that I have to solve problem of getting around to places, right? I only have to keep maybe a couple of weeks, right? Because I know where I'm going to be, but after I get to places, then I need to know where to get food, what's the best restaurant. So those are I would say relevant data, relevant information for me when I'm there, right? So basically, it's the who, when, where, and what, and basically all the context of the problem that you're trying to solve, right? So for me, right, I'm trying to get there, and make sure that I could get around, get to places, and speak, and be on time, and also enjoy the food there a little bit, right? So that's the problem that I'm trying to solve. So what's relevant and what's not relevant is determined by the problem that you're trying to solve, right? So if these data actually addresses those problems, then it's relevant, right? But what's relevant is specific to the problem, right? But if you have that problem, same problem as I am, then those same data will be relevant to you. If you don't have the same problem as I am, then those data would not be relevant to you.
Okay, so we were talking before about sentiment and social media, and I know that in your work you're very careful to connect the analysis that you do to what you call actionable results.
Yeah. So that's actually actually how to deal with the third classes of analytics. That's what I call prescriptive analytics, right? So maybe just let me give you an example of what prescriptive analytics is, right? So the simplest type of predictive analytic is a trend line, right? The simplest prescriptive analytic is, for example, Google Map, right? It tells you where you need to go. It's prescribed a route for you to get to where you want to go, right? That's in essence what it does. But just as in predictive analytics, it doesn't have to happen in the temporal domain. You can actually predict things, right? Predict people's sentiment in this sentiment domain, right? You can actually, once you have a model, you could predict things in the past, right? You could put Bible through this predictive sentiment classifier, and you can actually see when a particular character in the Bible is angry or happy or something like that, right? So you could predict things in the past once you have a model. So the same thing is prescriptive analytics don't have to happen in the geospatial domain also, right? They can also happen in the business domain, where the destination or the goal that you want to get to is some business KPI. For example, I want to achieve the highest customer satisfaction or the greatest lift in revenue. Those would be your business level KPI that you're trying to get to. And prescriptive analytic will prescribe you what you need to do, what you need to focus on in order to get to those KPI, right?
So how do you know, how does a business know what are the appropriate KPIs, and therefore what are the right type of analytics to apply?
Well,
how do you make that determination?
The business knows what KPI that they measure on, right? It's the same traditional business KPI, right? There is no difference. I basically, social media metrics, these are operational metrics. Number of impressions, number of fans, number of followers or that you have. All these are what I call operational metrics, right? These are not business level KPI, right? If you're, okay, let me step back a little bit. If your business is, the goal of the business is to have more fans for the sake of having more fans, right? I don't know if such business exists, then that would be a business KPI, right? But most business, don't have, are not out there to get more fans. Most business are out there to make money or to save money or to serve customers,
actually,
right?
Actually, if we think about many startups, especially social startups, who are not focused on revenue, their measurement is, do we have more fans? Do we have growing user base? Even though it may be free, even though it's costing them money, they're in effect subsidizing every one of those users. So I think that use case is a real one.
Yeah, so I think in that case, during those early phases, right, then those would be if that's the goal of their business, right, then that would be the proper KPI for them, right? But if your business is not, you have mature enough that for example, you have shareholders where you have to, make sure that they're profitable, then that would be your KPI, right? Not, you're not a startup anymore, then, if you're a startup, yeah, maybe that could be your KPI for a while, but eventually they will have to, shift over to the more traditional type of KPI.
So
they're pretty standard, traditional business KPI, yeah.
It's so Good Data just tweeted an interesting chart describing different types of analytics. And in addition to descriptive, predictive, and prescriptive, they added diagnostic. So when they say diagnostic is, why did this happen and what insights can I gain? So it sort of sits between descriptive and predictive.
No, I would say that that's still a descriptive analytics, right? Descriptive analytics tells you what happened, right? And you could use that data. I mean, so diagnostic or not diagnostic is really a use of the data, right? You could use predictive analytics or descriptive analytics or even prescriptive analytics to diagnose what happens in your business process or in your data collection process, your operation, and all that, right? So that's I would say an application distinction, right? I mean, I don't think that's how the data is being manipulated or model perspective.
So now regarding, let's go back to social media.
Okay.
So with social media, we tend to focus on what some people call vanity metrics. How many people like us, the things that feed our ego or make us, like you were describing earlier, or make us feel good.
Yep.
But you've made the point that those types of metrics are, and just simply looking at these types of metrics is far less important than actually understanding our customers and their needs and how are we going to get more customers. So maybe link all of that up for us.
Yeah, I think all these, whether it is descriptive, predictive, or prescriptive analytics, right? The ultimate goal is, to help business decision makers make a better decision, right? And also be able to take actions on the analytics the data that they see, right? So that means actionability is really important, right? Which I haven't really defined what it is yet, but this is actually a term that's been thrown around quite a bit, and a lot of people said they provide actionable analytics, but what do they actually mean? So maybe I would take a little digression a little bit to kind of discuss that a little bit before I answer your question. So you have to remind me of what your question is later, so I remember it. Yeah. So actionable analytics is basically, okay, it's a type of analytic it's also a prescriptive analytics, right? In the sense that prescriptive analytics mean, remember, you have to be able to tell you a course of action where you could take the action and affect the outcome, right? If you cannot take an action, then basically it's not prescriptive analytic, right? So with prescriptive analytics, there's actually two things that's really important. One is that there's we have to understand prescriptive analytics is actually a specific type of predictive analytics, in the sense that let's take a look at predictive analytics in the problem of a temporal prediction. Let's say you're trying to predict tomorrow's weather, right? So that's a very simple problem that everybody understands. And we know that if we look at the near future, let's say tomorrow or 2 days from now, right, we could predict the weather, uh, in these couple of days very well. But if we look further and further into the future, say, let's say a week or 10 days or maybe a month, right, then your prediction gets worse and worse, right? So there's this notion of what we call the predictive window. That means within this window, the error that you make in prediction is still acceptable to you. Okay, so that's what we call the predictive window. And when we talk about actionability, you have to have another measure called the reaction time, right? That means these are basically the time it takes for you to act or to take action against what you've learned from this predictive analytics, right? These predictions. So one of the most important criteria for actionability is that your reaction time had to be shorter than the predicted window. Okay, let me illustrate what that means. So say, okay, with the weather prediction again. So we could predict weather pretty good, right? Pretty well. Say for like a week, right? 5 day to 10 day, right? Something about a week. We could predict weather pretty well within that time range. If you try to predict further in the future, the error gets kind of pretty big and it becomes not very useful for us, right? So what's the reaction time for us to take action against the insight that we learn from these model, right? We probably, if we know tomorrow's going to rain, you just, bring an umbrella, right? It takes you probably a day the most, right, to take action against this. So in this case, the reaction time is to take action. It's about a day, right? But the predicted window is accurate up to maybe 10 days, right? So in this case, the reaction time is shorter than the predicted window, right? That means weather model today is actually an actionable model, right? Let's take a look at a more difficult problem. Let's say earthquake prediction. So today, earthquake prediction are actually not very good, right? So we can only predict maybe few seconds before the earthquake actually happens, right? So, but what's the reaction time for us to take action against these prediction, the insight that we learn from this prediction, right? If we know the earthquake is going to happen, right, it probably take us, on the order of minutes to tens of minutes, right, to get to safety, right, or prepare ourselves for earthquake, right? So in this case, the reaction time is tens of minutes, right, which is much longer than the predicted window, which is on the order of a few seconds, right? So in this earthquake model is what we call a non-actionable model yet, right? That means even though you could provide you with the insight, basically you can't really act on it. You have to prepare yourself, to get ready, to do preparation, ahead of time to make sure that when it's going to happen, you can act right away, right?
So we're just almost out of time, but we have another question from Twitter, which is an interesting one, and it connects back. We were talking earlier about social media and sentiment and all of that, and this is from Christopher Kelly, who's wondering if your thoughts on how we can measure the value of brand awareness if it's not monetarily, if it's not about money. Are there other ways to measure the value of brand awareness using data?
Yeah, I think ultimately it still comes down to money eventually, right? It's just that it may not come to your next quarter or but it may be 20 years later, right? Like the brand Coca-Cola, right? It's been around for so long. Like look at the value that of the brand there, right? So I think it still comes down to a monetary value eventually, but you have to look at a much longer time horizon there, right? That means a lot of factor goes into beyond just like awareness, right? People's sentiment about this particular brand and all that stuff. I think these all go into that, right? But it's not. I don't think this is a simple question to answer. I think you have to do a much more, I would say, longer time kind of analysis to see the long-term effect, right, in order to understand the value of a brand awareness, right?
And So we're almost running out of time again, but before we go, give us practical, simple advice, first for marketers, and second for individuals who want to improve their awareness on social media, because that's actually what everybody wants.
Okay.
And
All
everything
right.
else that you just discussed, notwithstanding, that's what everybody wants. Okay, so what does data
Okay.
tell us about that?
Well, I would say that, like for business, right, you definitely should start out with some business problem, right? I think data, as somebody have tweeted, right, when you don't have a problem, right, the data is actually not providing value, right? So that is true, right? But the thing is that like you don't know what problem you may have in the future, right? So the problem is actually very important. So if you can, if you want to have a big data initiative, a big data strategy, right? First, identify some problems, right? So that the data that you collected have more immediate value, right? Certainly, they will have a longer shelf life. They may have value. They may prove valuable, 10, 20 years down the line, right? But you don't realize those value until you actually address a problem 10 or 20 years down the line, right? So that's, I would say, latent value, right? You don't realize those yet, right? And then you basically have to see what kind of attribute or what information and what insights you could get from these data that are actually predictive of these business level KPIs, right? Whether it is revenue lift, brand awareness, right? In the long run, right, it still comes down to value, right? Um, so for individuals, I think there's I would say that there are lots of data out there about people's consumption of social media or participation on social media, and you can actually look at those data. Like I actually write a blog myself, right? And for me, right, I'm actually very interested in like how much should I write, how frequent should I write to get the biggest bang for my effort, right? Certainly, if you are a company, that may not be the problem, right? Certainly, if you put a lot of if you write more, right? Certainly, you are going to get more page view, right? But I actually are resource constrained. I don't have a lot of time, so I actually wanted to see, what is the I typically like to look at metrics, something like output per unit input, right? So how many page view I get per blog I write, right? So certainly if you write more blog, you're going to get more page view. But do you get a diminishing return when you write more? Like certainly if you write like one every minute, right? Not everybody, if someone could actually write one blog every minute, right? A lot of those blogs will just get pushed away, and then they won't get read, right? So you don't actually get a lot of page view per blog, right? You may get overall more page view, but you may not actually get more page view per block, right? But if you don't write frequently enough, then certainly people your readership drop off as well, right? So there is I would say, some kind of a middle ground where this, you will get the most page view per block that you write, right? So, and what's the frequency? What's the right frequency for that, right? For my own blog, I actually did some analysis. It turns out to be somewhere between 11 and 12 days. That's the frequency that I should publish. So to get the most views per block, right? So you do simple type of analysis like that for yourself as well. So to maximize your social media efforts.
Okay, well, this could go on for a long time, and I want to thank you. We've been talking with Michael Wu, who is the chief scientist of Lithium Technologies, and I hope I've understood a fraction of what you've told us today. And thank you so much, Michael, for joining us. It's been a very insightful conversation, and I really appreciate all of the tweets and the questions that we had as well. And I hope you'll come back and join us again, Michael, another time.
Yeah, it's my pleasure. I would love to come back sometime.
And everybody who's been watching, thank you so much. And to my friendly co-host, Vala Offshore, wherever you are out there in the world, I hope it's going well, and we'll see you again next week. And everybody, we'll see you again next week, same time, same place on CXO Talk. Thank you so much. Bye-bye.
Thank you.